Welcome to the Juniper Threat Labs attack demo series. Today's subject is TrueBot malware. Because the means vary by which TrueBot is delivered, this video will demonstrate a common threat vector used by malicious threat actors to attack and compromise victim systems. But first, let's begin with an introduction to TrueBot malware. TrueBot was created by Russian hacking group Silence, but its use is also linked to other collaborative or overlapping malicious cybercriminal groups, TA505, also known as Evil Corps, Fin11, and the Clop ransomware gang. TrueBot is today primarily a malware downloader. As such, it is a quote-unquote first-stage module, mainly used for downloading additional malware, including Flawed Grace, Cobalt Strike, a data exfiltration tool called Teleport, and the Raspberry Robin worm, which is itself linked with distributing TrueBot, Bumblebee, Iced ID, and even Clop ransomware. TrueBot adds the victim system to botnets, and it receives command and control instructions from its master to download and execute several file types, including .exe, .dll, batch files, PowerShell scripts, and shellcode. The master can also issue a bot command to terminate or kill TrueBot. TrueBot is very versatile, making it little wonder that there's been a surge of TrueBot malicious activity. The Clop ransomware gang, who were involved in recent hacks of a MoveIT file transfer software program vulnerability, uses TrueBot in its toolkit. Elsewhere, TrueBot was used in the initial stage of an attack that resulted in the wiping of master boot records, or MBRs. In that infection, TrueBot loaded Flawed Grace, then made a series of registry and print spooler mods, escalating privileges and establishing persistence. TrueBot later loaded Cobalt Strike. Then, following lateral movement across the network and deployment of Flawed Grace, the threat actors deployed the MBR killer wiper on all the other accessed hosts, before triggering a reboot, at which point all the hosts were dead in the water, unusable. All this began with TrueBot. TrueBot was also used by threat actors who exploited a Netrex auditor vulnerability, CVE 2022-31199. Still, the primary threat vector used to trick would-be victims into installing TrueBot is through phishing emails with malicious URLs in them. So that is the TrueBot example you are about to see. This is a typical TrueBot attack chain. It begins with a phishing email. The phishing email includes a malicious URL which, when clicked, typically leads to a drive-by download of the TrueBot executable. In some cases, the first malicious URL link in the email message redirects would-be victims to a second malicious URL before the drive-by download. In our example, however, there is but a single email having a single malicious URL. Now, with the background on TrueBot malware out of the way, next up in this video, Juniper Threat Labs demonstrates this attack. Let's get started. We're demonstrating this attack in a contained environment to show how it works. The victim here received a phishing email, which contains a malicious URL. Phishing emails are a kind of social engineering technique used by attackers who are trying to trick would-be victims into doing something. In this case, tricking them into clicking that URL. Once the victim clicks the URL, the browser is opened and the malware is downloaded. Though the naming varies from one TrueBot infection to another, in this case the malware is named document_5_June_54687.exe. While TrueBot is an executable, the malware authors are clever in that they've used a PDF icon to make it appear to the victim that he or she downloaded a PDF. This is a common technique used by threat actors. But as soon as the victim opens it, the malware is executed and it's game over. Though the malware displays a message indicating to the victim that the document is damaged and cannot be repaired, you and I both know that this was no document, but was instead the malicious TrueBot program. So at this point, the system is already infected. The TrueBot executable is now running in memory under process name runtimebroker.exe. The bot is just waiting for its master to send commands for it to execute, which, given that TrueBot is a first-stage malware downloader, the instructions typically involve downloading additional malware, as we've seen in recent TrueBot news. We can verify the communication of TrueBot to the master using Wireshark. For this variant of TrueBot, the command and control server is midnightwall.com. As shown, the system performs a DNS request before establishing a TCP connection to the server at IP address 46.161.40.128 on port 443. Once the TCP connection is established, the malware sets up a TLS connection to secure its command and control communication. Let's now look and see whether or not this attack works as successfully with the Juniper SRX firewall, enhanced with protection from Juniper's cloud-based advanced anti-malware solution, Juniper ATP. For the demo, Juniper Threat Labs is using the following setup. We have a VSRX pictured in the center. The VSRX is a virtual SRX firewall providing network security protection. Its purpose is to inspect network traffic, and with the assistance of Juniper ATP Cloud, to detect malware like TrueBot. In addition to the virtual firewall and cloud-based protections, we are using Juniper Security Director, which is a centralized management system. Security Director facilitates our configuring and monitoring of the VSRX firewall. And we are using Juniper's Policy Enforcer as well. Juniper's Policy Enforcer enforces security policies on endpoints and ensures they comply with corporate security standards. Pictured as well are several Windows workstations, each of which is connected to the VSRX. And finally, there is an Ubuntu server, which is acting as the malware download server. Before we proceed and run the TrueBot attack simulation, with protection provided by Juniper's connected security solutions, let's first take a look at the threat prevention policy that we've set up on our security director and applied to the VSRX. To access the policy, we'll navigate to the Configure tab, then we select Threat Prevention and Policies. As you can see, we already have an existing policy in place. Let's further inspect the protections being enforced by the applied policy. For this demo, our policy is configured to block command and control traffic at threat level 8 and above. We've also set it up to block infected hosts at threat level 8 and above. Additionally, we have configured our policy to use ATP Cloud for malware detection, and as you can see, we've elected to scan both HTTP downloads and email attachments. Finally, we've chosen to block any and all threats rated at level 7 and above. This threat prevention policy applied to the Juniper VSRX firewall is a critical component of our defenses, protecting our systems against malware-related attacks, including TrueBot. It allows us to detect and block malicious traffic as well as the activity of potentially infected hosts, which will then prevent the spread of malware throughout our network in the event one of our systems gets compromised. Acting as would-be malicious threat actors for the demo, we now connect to the victim system via RDP. Once connected, we will first confirm that we have internet connectivity, so we visit Wikipedia. After all, without an internet connection, the victim's PC would be unable to download the TrueBot malware. As shown earlier in this video, the attack begins with this phishing email that includes a malicious URL. Once the victim clicks on it, it immediately opens the browser, which then tries to download the executable as you had seen earlier. But this time, because Juniper protections are in place, the browser shows a message that it's being prevented from downloading the malicious file. We can also verify this through Wireshark. Here we can show the same message as the one shown in the browser. Ultimately, the good news is that Juniper's connected security solutions blocked TrueBot before it was able to get a foothold on the would-be victim's PC, and before it was able to add this PC to one of its botnets. Going back to our Juniper Security Director, we can find more details about this failed attack. Under the HTTP File Download tab, we see information about the detected malware, including the threat level, in this case level 10 for TrueBot, the malicious file hash value, and the URL associated with the malware. We can also click on the hash to find out more details. These details include a static analysis of the malware to show you different types of information collected by analyzing the static properties of the file. And behavior analysis, which includes information collected as a result of running the malware in a sandbox. We can see network activity and behavioral details, including processes that would have been spawned, as well as information about this malicious threat related to the MITRE ATT&CK framework. It's important to note that Juniper ATP identifies whether a file is a threat or not using machine learning, as well as the information just discussed, thus without the need for any signatures. Next, and again using Juniper Security Director, This time we'll look at the ATP Cloud Host tab. Here we can show you that the targeted victim system has been added to the infected host feed. In this case, not because it was infected, but because the threat level of the attack was 10, which well exceeded the level 8 threshold we had set in Juniper Policy Enforcer. For the time being, the host is disconnected from the network. The network security admin can click on that host to learn why it was blocked. In doing so, he or she finds that it was because of an attempt by the host's user to download a malicious file. To verify that the host no longer has internet connectivity, we'll try to RDP to it as before, and then try unsuccessfully, as you'll see, to ping it. Once the Network Security Administrator is sure that the host is free from infection, we will want to restore the infected system back to the network. To do so, we go to the Security Director and click on the infected host. To the right of the investigation status, we will select Resolved Fixed. Afterwards, the host status is now clean, and in just a few seconds, the host is connected once again to the network and able to operate as before. We can verify that the host is back online by pinging this PC once again. And we can RDP to it successfully this time as well. Finally, for good measure, we'll make sure that the host can browse the internet. That completes our demo of TrueBot malware. Check out more videos from the Juniper Threat Labs Attack Demo Series by visiting juniper.net. Thanks for watching.